Okay, class, I'm creating this Module 9, a Lesson 1 review. So after you've completed the review, if you want to go back and review your problems, this is going to give you all of the answers to all the problems if you have any questions on any of them. So, of course, you're going to click the Module 9, Lesson 1 review. Okay, and I've got it open right here. So we're going to go ahead and start that and jump right into it. All right, now the problems when you do these, it may be in a little bit different order, the answers, not the questions, but the answers may be in a little bit different order. All right, so this says which statements describe the figure, and it says select all that apply. Make sure you read the directions when you do these. All right, it has no parallel segments. Well, this one has a parallel segment. Remember, parallel means that they never touch. They never will intersect. As long as you can extend them, they extend infinitely. This one clearly will never meet this one, so it does have parallel segments. And this one says any two sides that meet are perpendicular. Well, perpendicular means they meet at a right angle. These are clearly squares in here. Squares have right angles, so these are going to meet at perpendicular. So I'm going to select that one. Of course, you always take a look at the hint if you want as well. It's an octagon. An octagon has 8 sides. Let's count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 sides. It's not an octagon. It has 8 sides of length 2 units. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Okay. If it has 8, then it doesn't have 6. Okay. It's a decagon. A decagon is a 10-sided figure. It does have parallel segments. We talked about it has no. It does have parallel segments. It has 2 sides of 4 length of 4 units. Let's see. 1, 2, 3, 4. 1, 2, 3. Yep. Mm-hmm. 2 of those. It has no perp. Yep, there is perpendicular sides. It has 2 sides of, and you can clearly see there's no sides with 5 units. Okay. All right, let's check it. And looks like we got the green box, so we're ready to go on. Next. All right, a quadrilateral is drawn. Quadrilateral, 4-sided figure. Which statement describes the figure? Okay. Has 2 lines of symmetry. So can I draw a line in 2 places that would cut this so I could fold it on top of itself and it would every side would match up. Every side would correspond. Well, it looks like I could draw one through here, but I can't draw and fold it over, but I can't draw one here and that fold over match. So it doesn't have 2. 2 pairs of congruent sides. It's actually the definition that makes up this shape. This side is congruent to this side. They're the exact same length. This side is congruent to this side. It's the exact same length. 2 pairs of parallel sides. Is this side parallel to this one? If I continue to extend them, will they meet somewhere up here? Yes. So this one has no sets of parallel sides. All 4 sides are congruent. You can clearly see that none of the sides are congruent. And since it does not have 2 pairs, it has no parallel sides. And we talked about it. It does have 1 line of symmetry right through the middle, going top to bottom. I could fold it over from this point here to this point here. Okay, let's check it. All right, good. We got all green checks. Now, this is what is a quadrilateral? So let's talk about naming all these. A rhombus, that's a quadrilateral that has 4 sides that are congruent. Now, a kite is a 4-sided figure that has 2 pairs of congruent sides. That's actually my answer. Okay. A trapezoid is a 4-sided figure with 1 set of parallel lines. Of course, you know a rectangle is a 4-sided figure that has 4 right angles and 2 sides that are congruent. Okay, let's check it, and we are correct. All right, moving on to question 3. All right, draw the horizontal diameter of the circle, then inscribe a triangle inside the circle that has the diameter as a side and a vertical line of symmetry. Use the polygon tool. Okay, this one is probably the one that you may have gotten hung up on when you did this one. Okay, so I'm going to draw my diameter. So I've got my diameter, and then I'm going to make it a triangle. So 1, 2, 3, 4, and I've seen I have my triangle. I drew the diameter, and I completed my triangle on the inside. I'm going to check it, and I got the green box. I'm good. Okay, so it was just a matter of 1, 2, 3, 4, and then I have my triangle on the inside. Okay, moving on. Okay, now drag the description to the box next to the figure it matches. I've got hexagon with one line of symmetry, hexagon with opposite sides parallel, heptagon with symmetry. Okay, so hexagon, that has 6 sides. Heptagon, that's a 7-sided figure. So let's find out which one is the 7-sided figure here. 1, 2, 3, 4, 5, 6. Okay, that's a hexagon. 1, 2, 3, 4, 5, 6, 7. There's my heptagon, and that clearly has symmetry. I could draw a line right from here to here and fold it on top of it. So there's my heptagon. Now, hexagon with one line of symmetry, because they're both clearly hexagons, I could draw a line from here to here and fold it on it. And the opposite sides are parallel. Those two sides are parallel, those two sides are parallel, those two sides are parallel. There we go. Check it. Good. Got all my green checks. Moving on to question 5. A quadrilateral with 4 sides that each measure 3 units in length, 2 pairs of parallel sides, and 4 lines of symmetry. So part A says use the polygon tool to draw the quadrilateral. Okay, so 3 units in length, 2 parallel sides, 4 lines of symmetry. All right, here we go. So 1, 2, 3. I need to make a parallel side, and it needs to be 3 apart. So I'm going to go down 3. 1, 2, 3. Oops, I have to reset that. 1, 2, sorry. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Basically playing connect the dots. All right. Now, does it have 2 pairs of parallel sides? Yep, that side is parallel to that one. That side is parallel to that one. Okay. Does that have 4 lines of symmetry? Sure. I could go through the middle here. I go top to bottom here. And I could go corner to corner here and corner to corner here and fold it over on top of each other. Let's check it. I got the green check. What shape is this? Hopefully you know that that is a square. Okay. Now, what's the radius of the largest circle that fits inside? Now, radius, if you recall, is the center of the circle to its edge. So if I drew a big circle inside here, what would it be if I went to the edge? Oops, I think I messed that up on accident. Well, what's the center? If this is 3 and I started in the center, how far would it be to the edge? 3 divided by 2 is 1.5. So it would be 1.5 units. Of course, you could type in with the numbers here or just type in 1.5. And if you need to look at the hint, the circle will be the same length as the side. If that helps. Check it. We got the green check. We're ready to move on. All right. Now, here's where I'm going to pull up the sketch pad to help you out. Betty is 5 more than 3 times Jaden's age, and Betty is 41 years old. All right, so I'm going to bring this down here, and let's see if this helps out a little bit. Okay, Betty is 5 more than 3 times Jaden's age. So, and Betty's 41 years old. So 5 more than 3 times. So, and it says that Jaden's age is 3, as Jaden's age is X. So 3x, all right, and then 5 more would be plus 5, and we know that it equals 41. Okay, so there's my equation. All right, so 3x plus 5 equals 41. And of course, you could use the numbers down here to type that in as well. I'm going to bring my sketch pad back up. All right, now I want to solve this. What do I need to do subtract 5. Do opposite operation. Subtract 5 from both sides. All right. 3x equals, what's 41 minus 5? Okay. Well, let's see. 41 minus 5, that's 36. Okay, 36. And then I need to divide by the coefficient of x. So I'm going to divide by 3. And 36 divided by 3, that's 12. So x equals 12. So what's my solution? 12. Jane's 12 years old. Hopefully that was helpful. Let's check it. Boom, we're good. All right, let's move on to the last one. All right, angles 1 and 2 are complementary. The measure of angle 2 is 2 times the measure of angle 1. Let x represent the measure of angle 1. Write and solve an equation to find the measure of both angles. All right, let me bring back up my sketch pad. I'm going to clear it out. I'm going to do a new blank sketch pad. There we go. All right. All right. So angles 1 and angle 2 are complementary. Complementary angles are 90 degrees. Okay. And x is going to be angle 1. Okay, so there's angle 1. And it said the other angle is 2 times the measure of angle 1. So that's going to be, of course, 2 times angle 1 would be 2x. And that's equal to 90 degrees because they're complementary. So x plus 2x, that's 1x plus 2x, that's 3x. So 3x equals 90. All right, then I divide both sides by the coefficient of x, which is 3. 90 divided by 3. 90 divided by 3, that is 30. So x equals 30. X equals 30. All right, so let's write in our equation x plus 2x equals 90. And of course, x equals 30. So angle 1 measures 30, and then if angle 1 is 30, angle 2 must be 60, because 30 plus 60 equals 90. And of course, you could have used this to enter it in as well. Check it. Got all green marks, and I'm done. Hopefully this video tutorial was helpful for you.